Hi everyone, let's solve this problem. First, we need to do the derivative. So we get 3x squared and 2x minus 1. Let the derivative function be 0. So 3x squared plus 2x minus 1 equals 0. Use the FOIL method, 1, 3. This one, 1, 1, then we have to put a negative, then here is positive, so we know this is negative. So we get x plus 1, 3x minus 1 equals 0. So we get the critical value, x is negative 1 and 1/3. Now, because this 2x separate this x-axis to 3 intervals. So negative infinity, negative 1. Here is negative 1, 1/3, 1/3, and infinity. So in each interval, we choose a simple, we call simple easy number. In this interval, we choose x equals negative 2. Now let's do the derivative when x is negative 2 is here. So negative 2 plus 1 is negative, right? You don't need to get the exact answer out. Just we want to know greater than 0 or less than 0. So negative 2 plus 1 negative. Negative 2 times 3, negative 6. So here negative. So 6 is negative times negative. We know this is, no, here is positive, right? Positive, no, this original function f of x. So since the derivative greater than 0, so this f of x original function is increasing. Now for the second interval, we choose x equals 0. Now let's see the derivative when x equals 0 is greater than 0 or less than 0. So here 0 plus 1, 1. Greater than 0, 0 here. So positive, negative, now we know is less than 0. So that's the decreasing. This function f of x is decreasing. So I add here. So f x increasing, here f x is decreasing. Now let's see the last one. So we pick an easy, simple number. X is 1. So 1 plus 1, we want to see the derivative, right? 1 plus 1 greater than 0. 3 minus 1 greater than 0. So greater than 0, greater than 0, positive, positive, we know is greater than 0. So original function is increasing. So we know you climb mountain, go up, then go down. Here, this negative 1 is a maximum, right? It's top of mountain. Here you go down, then you go up again. This is minimum. But those we called local, or you could call relative. This is local, minimum, and relative. Absolute means global. X is in this interval. So that means x less than equal 0 or greater or equal negative 2. So now we are able to find the global maxima and minima because you not go to negative infinity or infinity. Okay, so now we need to compare all those critical points and the end points. Compare then which one is the biggest, that's the maximum. Which one is the smallest, that's the minimum. So now let's see the local maxima is x is here, right? Negative 1. So what's the y? Y is that's why we call x this value called critical value. But if we want to call the critical point, because one point related to values, right? X and y. So you need to get a y. The y value is based on the original function. So you replace x is negative 1. Let's do it. Always use the parentheses. Be generous, use the parentheses for the negative number. So here we get 8. Now let's do the local minimum. X equals 1/3, right? So we call negative 1, 8, this is a critical point. If just x value, we call critical value. So when x equals 1/3, now we also replace x by 1/3 into the original function. I got 622 over 27. Then we need to do the two end points. So when x equals negative 2, what's the y value? So you just get this negative 2 out. Also, I just save time. I get 5. Then another endpoint is the upper bound, right? X from negative 2 to 0. That's the given condition. So y should be, so you replace x value in the original function by x equals 0. So that's 7. So we get 4 numbers. We got 2 local critical points. This is the maxima and the minima is a local relative. Also, we have the end points, 2 end points given. So now let's see which one is y is biggest. You see here, 8 is y is biggest, right? Then this one is y is smallest. So now we know absolute, or you can call global maxima is -1, 8. Then the global minima is here -2 and 5. So that's you get the answer.